start again with the same topic, that is the model slicing. Okay, and we will further proceed with the discussion in the same topic. Okay, and by today I expect we will close this module 1, and then we will go to the module 2. Okay, so in today's discussion, in fact, if we revise from the previous session, then we will be discussing we have discussed about model slicing, and in this model slicing we could see that we have hierarchy sorting, then contour sorting, right? So okay, so in hierarchy sorting, what we are doing, we are building a parents on list, and which is basically defining that which contour is containing other or the contour, if it is containing other contour, then we see the parent son relationship. Okay, so we took one example in the previous class, that in this particular uh, component, or the model, we could see that we have C1 as parent and C4 C5 as their son. Similarly, here again we have C2, C3, C7, C6. So here also in this C2 is son of this external contour, or you can say C1, and again this C3 is son of C3 is you can say parent of C6. Okay, so this way we could identify, we could build the parent son relationship, and that was used in hierarchy sorting, or in order to find out the hierarchy between these different contours. Okay, so this I hope this discussion is clear to all of you. Any student who is having any query? Otherwise, we will move to the next part. Okay. Yes. So today, basically, we are going to talk about adaptive slicing. Okay. So till now, we have discussed about slicing or model slicing, and where we have assumed that we will be, we are slicing the model with some constant thickness, or you can say constant layer height. Like in this case, uh, you can see this is your ideal surface, or the desired surface, and if you are having suppose this height is suppose say 15 millimeter. Okay, for example, say it's 15 millimeter, and you have 3 layer. You want to print this particular surface, particular component. uh, you have made 3 slice, maybe this slice is 5 mm, again another layer of 5 mm, then last layer of 5 mm. So what we could see within 3, if we go with constant constant thickness, if we elaborate more. Okay, so during these slicing, what is happening, you can see there is an error. Okay, let me draw in 2D here, something like this, some surface, something like this. Okay, and what you will see, suppose this is your first layer, then second layer. Let me create it. Okay, suppose some shape, something like this. Okay, so this is your first layer. Okay, then you have second layer, then it is your final last layer. Okay, so if you see what will be your it is not actually coming. Okay, let me draw it in here. Okay, so if you slice this, consider it as a half circle. Okay, so if you slice it, you will get layer something like this. Okay, your layer would be something like this, that you have got in your this particular figure. Okay, so what you will see, if you are having your thickness too high, you will get staircase effect. These surfaces would look like a stair. Okay, so obviously this staircase case effect would result into the inaccuracy in the your printed part. Okay, if you are having larger layer thickness, your staircase effect would be very high. But if you see here in the second diagram, this is your first case, and in the second diagram, if you see, when you have reduced your layer thickness, suppose now in this case, instead of 5 mm, because here your layer height was 5 mm. Okay, now suppose you are using the layer height 2 mm. So what is happening, your staircase is staircase effect is reducing. Okay, staircase effect is reducing. Your printed surface is more near to your ideal surface. Okay, as compared to as you are getting in your surface when your layer height is too high. Suppose here it is 5 mm, then here it is 2 mm. And again, suppose you further you want to reduce it, you can make it 1 mm in another path plan or another slicing pattern, and you will get more accurate surface as compared to your first case. Okay, so in first case you have 5 mm layer thickness, in second case you have 2 mm layer thickness, and third case suppose you are having 1 mm thickness. Okay, but when we see this is at the part of accuracy part. Okay, you will have more accurate surface as soon as you are reducing the thickness of your layer height. But at the same time, what is happening, suppose here what would happen to your production time. In this case it will be very less, in this case it will be little bit more. But when you have reduced the thickness 1 mm, it will be too high if you compare with your first case. Okay, so we have to make a compromise in between your layer thickness and the or you can say, instead of layer thickness, you can say the quality of surface to be produced and your production time. Okay, so in between you have to make certain compromise. Okay, so yes, in this slide these are the disadvantages, or you can say issues with your constant thickness slicing. Okay, if you are going with constant even if you are having in some cases, even in this type of in the first case, suppose your shape is something like this, suppose you want to print something like this. Okay, so in this case obviously you if you take a larger layer height like this. Okay, if you are having 5 mm 5 mm, because all the surface is not having any feature, or the surface is rather you can say vertical in nature, then you can go with larger layer thickness. Your surface quality would not be much affected whether you are having 5 mm layer thickness or you are having 1 mm layer thickness. Suppose here you are having 1 mm layer thickness. Okay, for these type of component, it is not going to much affect the surface quality. But for the surfaces which are having features on it, then you have to make a compromise in between the surface quality and the layer height. Okay, or the layer thickness. Okay, so The possible disadvantages with constant layer thickness are, uh, there is possibility of missing features that you if you are having certain features, suppose some curve is here at this point, so there is possibility that you may miss this particular feature because it is much smaller than the layer height. But since you have increased the layer height, decrease the layer height in the second case, you may get this feature due to the reduction in your layer height. Okay, so uh, or or let me take one more case. This is your first case, this is your second case, then let me take another case. Suppose you are having some component something like this and you have some feature on it. Okay, okay, so what we can do, uh, up to this point we can go with larger layer thickness. Okay, we can go with suppose 5 layer thickness, but in this region, because since there is a surface feature, you can go with a smaller layer thickness, suppose 1 or 2 Okay, so suppose you are going with 1 layer thickness. So this is what it is called as adaptive slicing. Okay, we are choosing the slice depending slicing height or the layer thickness depending upon the feature on the surface of or the quality of surface to be produced. Okay, so in this case, what is happening, you are having combination of large thickness as well as small thickness. Okay, small layer thickness. So when dealing with curved parts, an inconsistent surface finish is likely to appear if you are going with constant layer thickness, because if you choose constant layer thickness, sometimes if it is too low, or you can say if it is too much less, then your printing time or the production time will be very high, and if it is very high, then you are going to lose the feature on your surface. So we have to make the compromise in between these two, that where there are no feature you can go with larger layer thickness, and where there are feature in the surface you can go with a smaller layer thickness. Okay, yeah. Yes, this I have discussed. Constant thickness slicing tends to increase in building time, because in order to make in order to get the features on the surface, we have to reduce the thickness of layer, and that we have to do throughout the product. Okay, throughout the printing of your product. Okay, so this constant thickness slicing approach leads to increase in build time. Okay, so I guess you are able to understand why this adaptive slicing is important. Okay, so let us try to see with more at the level of when by comparing two printed layers. Suppose this is your deposited layer, and you are supposed to print another layer on this particular layer. Okay, so here the basic principle of adaptive slicing is to evaluate locally the surface characteristic to select layer thickness. Okay, so what we are doing, we are selecting the layer thickness to be printed. Suppose this is Z. Select layer thickness that restricts the maximum surface error, usually measured by cup size. Okay, so suppose in this case we are having this maximum error will be this much. Okay, so this maximum error, or you can say that deviation of surface, it is given by cup side. Okay, the name is cup side. So cup height is the parameter, okay, basically, which is deciding the surface quality, because we there may be certain given value that cups the maximum possible error should not go, or the maximum surface error should not go beyond, say, 0.1 mm. Okay, or it is given, say, 0.5 mm. So how will you choose your layer thickness? You will choose the layer thickness in such a way that this cup's height does not increases with the given maximum surface error. Okay, so it should not increase with the maximum possible error. Okay, so this is how the surface quality is maintained while producing the component with adaptive or slicing the component with adaptive slicing. Okay, yes. Okay, so let us move ahead. Just a second. Yes, yes. Okay, so here we can see. Suppose we are having a this is your this is our original plane. Okay, or the surface, ideal surface you can say, which is supposed to be printed. Then this is your previously printed layer which is printed on it. Then uh, then you are printing another layer, second layer, okay, on it. Okay, so here what actually we are trying to see, we are trying to identify, we are trying to get the cup site. Okay, or through cup site, because cup site will be given, you will have certain value. Suppose this should not be go beyond 0.5 mm or some value. Okay, some value would be given, it should not exceed from beyond it. So suppose the angle between the surface normal and build direction, because our build direction will be where, in which direction, your build direction will be this, and the normal to the surface, that is because this is your original plane surface, and normal to surface is this. So suppose angle between these two is theta. Okay, so using this relationship you can find out the layer height or the layer thickness, uh, because here you can see, because this is normal to it, so this will be theta and this will be again theta. Okay, so and since this value is L, this value is L, so you can calculate H L equal to, you can calculate H equal to L cos theta, right? Or you can say L equal to, or the layer height equal to H upon cos theta. So this way you can calculate the layer thickness, what is the amount of what is the height through which your layer should be printed on your previously printed layer. Okay, so again, okay, so there will be, multiple number of points on which you will be interested to print. Suppose once you have printed this, you will go to the next set, then you will print another layer, then you will print the next layer. So there will be, every time you have to check this surface normal or the normal on your on your original plane or your surface, and its angle with your build direction. Suppose you are having some surface like this, so at this point your surface normal will be in this direction and your build direction will be this. At this place your surface normal will be at this and your build direction will be this. So here we can see your surface normal, the angle between your surface normal and the build direction is decreasing. Initially it is high and later on it is increasing. So high theta, it means cos 90, it means if it is near to cos 90, then it is corresponding to 0. Okay, and when this this cos theta is increasing, it means when it is sorry, it is decreasing when because when we are moving upward, it is decreasing. Okay, so as soon as this theta is decreasing, the value of cos theta will be increasing, or it will increase from 0 to 1. Okay, so the value of theta, value of this term cos theta will be in between somewhere. Okay, it will not be 0 obviously, because initially we will take some layer thickness, okay, say 1 mm. Okay, so depending upon the direction of your build direction as well as surface normal, you will get the value of theta. So initially you will have some value very less, and it will increase from it will be slightly less than 1 at the end of this particular surface. Okay, so this way you can choose the adaptive layer height when you are printing the, or when you are slicing the component using your adaptive slicing method. Okay, so this is again yes, it is already discussed. Okay, okay, so this is again analytical formulation. I have taken it from a paper. Let me show it here for your reference. If you want to read more, you can read it. Let me open. Yes. Adaptive slicing, right. So there is one paper by Sabreen. Okay, I have taken these details from here. So if you want to see more about this, you can see here I have just taken formulas only. Okay, those who want more clarity, they can go through this paper. Okay, let me show its title. Yeah. Okay, so here these layer height, or the formulae has been written how this layer height is determined at any point of just a second. Yes. Okay. Yeah. Again, yes. So here you can see the results that have been discussed in that particular paper, that if you go with adaptive slicing, your surface quality will not be deteriorated, as well as your production time, or your build time is reduced. Because why your build time is reduced? Because instead of using uniform thin layer, here you can see the comparison between these like in uniform thick layer, it means you will not get good surface quality, but your build time is relatively low. It is very low. Let's say it is 30%. Okay, and when you are going with very uniform thin layer, then you are getting good surface quality, but your build time, suppose it is rated as 100. Okay, so as compared to 100, you are able to print your whole part by using uniform thick layer when you are having very high layer thickness. Okay, so you are taking only 33% of time. But the new approach, by the combination of these two, wherever you are not having surface feature, you can go with uniform thick layer, and wherever you are having surface feature, you can go with thin layer method, and you are able to print this part in 48% of relative time. Okay, so this is the comparison you can see here. Yeah. Okay, so again the same process continued. The difference between your constant slicing, then adaptive slicing. Okay, here nothing to elaborate all these. Yeah. Okay, so there are the few more cases. You can go through it in the paper that I have shared. Okay, and we can say it is the end of your module 1 with the discussion, and we will start your module 2 from the next